A behavior baseline is a model of what normal usually looks like. It is not a magic list of good and bad actions. For SecurityX, the senior level idea is that users, systems, and networks all have patterns. Monitoring becomes stronger when you can compare current activity to those patterns and ask whether the difference is meaningful. A static threshold says the same number is suspicious every time. A baseline asks what is normal for this entity in this situation. 10 failed logons may be ordinary during a password reset wave, but unusual for a service account at 2 in the morning. Baselines improve monitoring because they include ranges, timing, role, and historical trend. User baselines describe rhythm. When does this person normally log in? From what locations? Which applications and datasets do they normally touch? Peer groups matter too. A finance analyst and a cloud engineer can both be legitimate employees, but their normal access patterns should not look identical. The baseline helps an analyst notice impossible travel, unusual privilege use, or unexpected data access. Systems have baselines too. A server has expected processes, services, ports, resource patterns, maintenance windows, and configuration changes. Drift is not automatically malicious. It might be a patch, a new job, or a business growth. But drift that appears outside normal change windows, repeats across critical systems, or aligns with other suspicious signals deserves attention. Network baselines describe traffic lanes. Which systems normally talk? Which destinations are expected? What protocols, ports, volume, and time windows are normal? A new outbound path from a database server, a sudden spike in encrypted egress, or lateral traffic at an unusual time can be more useful than a raw count of packets. Aggregate analysis looks across many events instead of overreacting to one. A single failed login may be normal. A rising failure rate across one department, one source network, or one application can show a trend. Aggregation helps the SOC see distribution, rate, seasonality, and outliers without turning every small deviation into an incident. Correlation asks whether separate baseline changes tell one story. A user logs in from a new country, a workstation starts a new process, and a database opens a new outbound lane. Each signal alone may have an explanation. Together, they may deserve fast investigation. Context can also lower urgency when change aligns with an approved deployment or planned travel. Baselines should help prioritize, not just generate more alerts. A small deviation on a critical identity system may matter more than a large deviation on a low-value test box. Confidence rises when multiple anomalies align, when the asset is sensitive, and when the change violates expected business context. The best queue is not the longest queue, it is the queue ordered by risk and confidence. A baseline is not finished after deployment. Business activity changes, cloud workloads move, users travel, and attackers adapt. Analysts need a tuning loop, measure results, review false positives and missed signals, update features and thresholds, and document why the model changed. Mature operations treat baseline tuning as detection engineering, not as a one-time checkbox. Knowledge check. A payroll user logs in at an unusual hour. Their workstation launches a process not seen before. At nearly the same time, the payroll database opens a new outbound network lane. What is the best response? A. Ignore the user event because one late login can be normal. B. Treat the three baseline changes as correlated context and prioritize the investigation based on asset criticality and confidence. C. Disable all baselines because they create noise. D. Alert only when a static packet threshold sleds. The bets and ein mo. The key takeaway is that baselines turn monitoring into comparison. Users have rhythms, systems drift, and networks follow traffic lanes. Aggregate analysis shows trends. Correlation adds context. Prioritization focuses the SOC on risk and confidence. For SecurityX, the senior answer is not to chase every odd event. It is to spot real change, explain why it matters, and tune the model as the environment changes.